Hey, hello, and happy Sunday. This is PFG.Live, the podcast that reminds you to remain coherent, at least for the next hour. Welcome aboard. CJ Stevens is in East Tennessee. Welcome, sir. Carl Tauber reports 34 degrees Fahrenheit and cloudy in the People's Republic of Rhode Island. Let's see. Ron Kellis says hello from cloudy South Washington State, 45 degrees and holding all day. Welcome, sir. Stan Workshop says 11 degrees science and cloudy in Digbeth, UK. Welcome. I hope I pronounced that right. DBX near the White Plains Airport is reporting winds are 100 at 8 knots, visibility 10 miles, clear, temperature 02. Dew point minus 04, altimeter 3072. Tucker is reporting 38 degrees Frankenstein and very cloudy and depressing in Buffalo, New York. Josh, under gray skies in southern Manitoba, right next to Charlie X-ray Mike Delta, reports winds are 160 at 7 knots, temperature minus 02, dew point minus 03, and the remarks have something to say. He says it was minus 35°C with wind chill 3 days ago. Dale is reporting minus 9 degrees science and falling with clouds in the northwest of Snow, Mexico. Josh, our audio checker, says, check, check. Rommel says, in Geneva, Switzerland, it is 2 degrees centigrade, partly cloudy. Welcome aboard, sir. Ugly Skull reports 24 degrees science, clear skies, 26-kilometer visibility in the Philippines. Welcome. Hey, we have a good crowd. So, as you are no doubt aware, we are going to talk today about lasers, or they are sometimes called frickin' lasers. We had some wins this week that were pretty cool. I'll tell you the story in a few minutes that ends up in lasers, but it was mostly about servicing your clients or not servicing your clients. Let's see. This week in the shop, what did we do? We got orders out. We're 100% caught up on orders. That is exciting. So if you need yourself some PFG Stones, head over to PFGstones.com. Let's see. So why are we talking about lasers? So I have this project going on in the shop. And this project involves, in part, etching some parts out of 25 thousandths brass. So over the years, I design antennas when I'm wearing my other hat. And over the years, I've made some parts for my client projects out of brass. And here's an example of one. I have it turned around so you don't see the name of the client, but basically this is a part that I designed that you fold it up and it becomes an antenna. And that was for the client's project. And the easiest way to manufacture these things is by etching them in a brass. This particular one is tin plated for solderability. And then it gets folded up or whatever. And that works out just spectacularly well. Unix Carbide is checking in East Village, New York City, 39 degrees Fahrenheit with the screaming young race car engineers. If you pop in Unix with a little live video feed, even if you have no audio, I'll try to get you. I'll try to get you on so we can show everybody what's going on because I think it's cool. So, anyway, time passes, and Roger that, sir. He says he's on a hardware store run. So he's got. If you're familiar with like the Cub Scouts do Pinewood Derby. The school system that Unix Carbide is involved with, they've been doing these similar car races with the kids. And they've done a couple of cool things. One of the things they did is they minimized the design of the car to be as simple as can possibly be. including, getting stuff from the hardware store and cost of parts. It's really neat. And we did get some live video from him in the pre-show, and he was having a great time with these kids. They're awesome. And now he's off on a hardware store run. What a shocker that you have to go to the hardware store to get more stuff. That's totally cool. So back to our story. So time passes and a project pops up. I've been working on a project for the last few months, and we're getting really close to popping out this thing, which one day I think we'll talk about in more detail if I get permission from the client. But inside this thing, there are etched brass sheet parts, not entirely unlike, this sort of a thing, except they're actually a little bigger. So think of a 3x5-inch file card with some interesting things etched out of it. Well, I went to my usual supplier, who I've known and used over literally the course of about 25 years, and they are down in Massachusetts, on the south border of Massachusetts, actually on the southeast border of Massachusetts. And I sent them a RFQ, and I get somebody calling me back, and they said, "Hey, we just want to check with you on what's the probability that this is going to turn into a lot of business." And I'm like, because it's a small order. It's a relatively small order. I said, well, I was very clear in my RFQ that this is essentially an engineering project. Small number of parts, attention to detail, and get it done. And I've done this with you before, over the course of the last century. Okay, quarter century. And they said, they're kind of saying, well, management is trying to get us to not take small projects, only take stuff that's going to be, big on the bottom of the spreadsheet. And I'm like, well, you're advertising that you still do, innovation and engineering, and that's what this is. And I've used you guys for 20-something years. And this is very nice person said, okay, well, if you can give me something I can go back to management with. I said, well, and then I gave them some hints as to what this thing was used in, and it was a pretty important project. And they were like, okay, that's good enough. I'll get back to you. So they disappear, and sure enough, several hours later, same day, I get an email with the quote. So, etched metal part, okay. The one I'm holding on the screen is a little smaller, but you get the idea. Effectively 20 total of these, 10 of one, 10 of another, okay? Quoted price without material cost, about $7,000. If you asked me before I sent this, I would have guessed this was going to be a $1,500 project, maybe a little more. I'm taking into account what it would have been, 5-10 years ago, and then I'm upping it a little bit. No, $7,000. So I was really kind of ticked off about this, and I was grumbling under my breath. And my wife says to me, well, you have an I don't want to do it price. They just gave you their I don't want to do it price. I laughed. I'm like, you're not wrong. That was exactly correct. They gave me the I don't want to do it price. So I'm mumbling and grumbling, and I was on our Discord server hanging out while I was doing some work, which is not unusual on our Discord server. Some of us work alone, and we get on there and just have company. So Dale, WidgetWorks, I have him to thank. Dale says, your laser will cut that brass. And I'm like, well, I know, I tried it, but it, blah, 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 excuses. This goes on and off for hours. And finally, I'm like, okay, I've had enough. And I go downstairs and I find myself a chunk of brass, and I make a little circle in Adobe Illustrator, and I realized that I had never experienced with vector vector cutting on the laser. All of the work that I had done on the laser has been raster marking. Okay, and in fact, the thumbnail for our show today shows a nice marking on some steel, and that's sort of the kind of stuff I've done. And I said, we'll give this a try. So I created a circle vector, and I went downstairs and we came up with a recipe for it. And we'll get back into the nitty gritty of how these things work. But on my laser, which is an Epilogue Edge, Fusion Edge 24, I think it's called. It's 12 by 24. It's a gantry laser. So the laser head moves around on a gantry, and the parts are on a 12 by 24 bed. So it's not unlike a gantry milling machine. So so the recipe I gave it was, first you had to select vector instead of the raster graphics for that particular process, which I did. And then I said 100% power, 10% travel speed, which translates to some, travel speed, kind of slow, 1% frequency. Now, don't get me started, because it's not the frequency. It's a duty cycle. They don't ever explain it. And it's my big pet peeve with these things, especially with Epilogue. It's one of my few pet peeves. Is what do they mean? But we kind of know what they mean. It means we're pounding it with these very short pulses. So 1%. So I fire this thing up. Oh, and the last parameter was 100 cycles, because I figure it's going to take, some large number of passes to get through the 0.008 of an inch brass. So I'm talking to the guys on Discord live, and I fire this thing up, and it goes in, it starts going around the circle, and it's making a very nice mark. The kerf of this of the laser mark was probably 0.003 of an inch. It was very impressive. So it goes around the circle, and I'm counting the number of times it goes around the circle. Round about the 6th time it goes around the circle goes tink, and out pops this this circle of brass, and it was delightful. So I was very happy that it did work, and I was very happy that I gave Dale the opportunity to say, "I told you so." So there's a picture, if you're on video, there's a picture of the piece of brass taped down to a piece of aluminum. And then we did some further experiments. I used some cyanoacrylate superglue, the very thin stuff, and I glued the brass down to the aluminum, because that's a method that I use for machining thin material. And I wanted to see if the laser would play nicely with the cyanoacrylate. So I did that. Same thing. Went around the circle, and it did really well. I actually stopped it after, I think it was after 8 passes, and I went in there with a razor blade and I popped it out because it was still stuck due to the glue, and it came out absolutely beautiful. And that was the second one, this one right here. So they had, like I said, a very small kerf, and the burr that was raised on these things was 1,000th burr, maybe 2,000th burr. And then I just took a PFG stone. Go to PFGstones.com. I took a PFG stone and I just basically rubbed it on the PFG stone, and it took off the burrs off the edge pretty quickly. So that was a win. And then I went ahead, I made some other little minor process experiments, and then finally put a different Dale said, "Why don't you make some Christmas ornaments?" So I made this. I made this little star wrapped around a hole, which was already existing on that piece of brass that you see, and it came out absolutely awesome. So it was a huge win. Now here's the point. I got off my butt and I went down and I did this experiment that Dale had an existence proof that this was going to work, and I did it because I was so pissed off at this $7,000 quote. So the next thing that happened is I ordered the correct thickness brass. I also ordered copper as an experiment. They're going to be here tomorrow because of our favorite yellow catalog, McMaster Carr, and I will do some further experiments. Now, the other thing that happened immediately after I got this quote was I sent out an RFQ to 6 other companies around the country that do this kind of work, and those are going to be coming in. One of those companies got back to me not only with an acknowledgement of my request, but they had already laid out my parts on sheets that they can etch, and they sent me the images, the DXFs or whatever of the sheets. And they said, could you indicate to us where you want the tabs? They were literally half done, and they hadn't given me the quote yet, compared to these other guys that wanted to make sure I was important enough to do business for, to do the work for, and then gives me a quote of $7,000. So there's a whole bunch going on here. Okay. The big thing, and this is sort of the secondary topic of my discussion today, is do you do the stuff in-house or do you outsource it? And of course, my knee-jerk reaction is to outsource it because I'm no expert. DBX says, please live stream the experiments. Absolutely. That's a good idea. Maybe we'll do that. Stay tuned. I don't know when it's going to happen, but we can do that. So I have a lot going on to get this project out the door. My client wants me to get this project out the door. So I'm like, I've already outsourced the machining, which I was originally going to do in-house to expedite it. Here's the etching. I was going to outsource the etching, but now I'm really, I'm in a conundrum. I can probably do this all in-house, and we'll see what happens. So if you had to ask me what I think the most probable outcome is for this particular situation, do you outsource it or do you do it in-house? I'm going to guess that on this project, I'm going to get an excellent quote from these guys in Santa Clara, California. And I'm probably going to push the button with them and let them make the parts, but I will continue the process development to make these parts in-house because I can. Now, if you go back a decade or more, I couldn't because the laser does a job that you really can't do on a milling machine. I mean, look at the star here. If you needed those included angles to be sharp, you're not going to get it because they probably have a radius of about 0.03 of an inch. So that would have been really painful to do, not on a laser. And that's why we used to do it by etching, because in etching, you can do it. So I am going to proceed. I'm going to get this process going. I think that if I can make parts in brass at 8 thousandths thick, which is what these are, I don't think I'm going to have a problem making parts in brass at 25 thousandths thick. It's just going to take longer, and there might be a little more complication in the process, but I don't think it's going to be a lot. So that was my story as far as getting the quote, getting steamed up about it, deciding I could do it in-house. Maybe I'll continue looking for outsourcing it, and we'll see what happens in the next few days. But the same is true. The same can be true for laser marking. or marking in general. We could have sent stuff out. Now we're doing it in-house. So the story of me bringing the marking of the PFG stones in-house, and the reason I own this laser was because I was aware of the lasers. I knew what they were capable of. And it wasn't justifiable for a long time. Hey, Ron. Ron says, good, quick, or cheap. You could have any two. How valuable is time? He says, I'm the Instagram guy who was happy to leave you the New Hampshire snow. Thank you very much. Yeah, you're exactly correct. So I told this story before, but it's worth telling again under the heading of lasers. I've known the Epilogue guys and my local rep for literally a decade before I pulled the trigger, because it was really cool and I really wanted one, but I couldn't justify it. And then one day I popped up in bed and I said, I wonder if I can laser mark the stones. And if you have a set of PFG stones, and if you don't, go to PFGstones.com. You'll note that they're marked on the side, okay, in the fine portion of the stone. And that was something I really wanted to do. So I call up the rep and I said, hey, I want to come talk to you about this laser. And of course he had to roll his eyes because it's the 10th year I've talked to him about the lasers. So we set an appointment, and Sam came with me, and we grabbed some stones and went to visit this guy. He wasn't terribly far away. He's about 20 minutes away. And I handed him a stone, and I handed him a thumb drive with my nomenclature on it. And I said, I want to put those markings right here. So he thought for a minute, and he set it up in the machine, and he guessed. He guessed at the recipe. He hits the button. After a couple of minutes, he pulls the PFG stone. Well, it wasn't a PFG stone yet. He pulls the stone out of the machine. He hands it to me. I look at it. It was perfect. I looked him in the eye and I said, sold. And I think he was going to have a coronary just from the shock, but it pushed me over the edge and I was glad. And in a minute, we'll talk about why that worked, because it wasn't obvious that it was going to work. In fact, it could have failed completely and I wouldn't own an Epilogue laser today, but it didn't. And I do. And I'm a very happy camper. The cost on that machine was, I don't remember. I should have prepared a little better for that, but it was more expensive. So what I bought is a fiber laser. Now we can get into the different types of lasers. People had already, people in our community had already purchased lasers. A lot of people bought CO2 lasers that were pretty big. John Saunders had a Boss laser, I think it was. So this is a fiber laser. That's a CO2 laser. And now if you go on to Amazon or whatever, like I was talking to WidgetWorks, some of the diode lasers are quote blue lasers, and those are interesting. So the big differences amongst the lasers is the wavelength. So a CO2 laser, a fiber laser, and a so-called diode laser, you have to ask the question, what wavelength is it? Some of the first lasers that we were exposed to, if you'll pardon the pun, were like laser pointers, right? And what color was the dot? The dot was red, okay? And that was because that was a helium neon laser. I happen to have an artifact to show you. I apologize for the guys who are audio only, but we'll give you an audio description. Okay, so this is the power supply for the laser, okay? It plugs in the back. A key switch in the front because of the evil laser beam, okay, for safety. Oh, by the way, this laser was loaned to me about 25 years ago. And then the power supply comes out the back. So that's just the power supply. And then here is the laser itself. So this was the laser tube, okay? You can see the wire coming in the back. And this tube is approximately, let's measure it. It's an aluminum housing. It's about 1 3/4 inches in diameter, and it's approximately 11 inches long, okay? And if you search around on it, you could find this danger warning label that says that this is 5 milliwatts maximum output, okay? And then this is designed to be mounted probably on an optical bench to do some fancy experiments. But if we turn this on, and we're not going to, if we turn this on, you'd see a dot that is a helium neon laser, a red dot. So it's pretty easy for us to grok that red is the color of that laser. Well, here's another laser. This is this couldn't be more different. This one takes a rechargeable battery. I got this off of Amazon. And this one is a green laser. And this one is also in the same category of 5 milliwatts, I think, or less. I haven't double-checked that. But, you know, this is what happens 25 years later. You have a solid-state laser, not a tube. It's more like a diode, a laser diode. And this one is green. So if you look at the chart that I put up on the screen, the entire visible spectrum is pretty teeny on this chart. Green is listed right there at 532 nanometers. Let's see, the classic red laser, the Heaney laser, is not on there, but it's probably on the order of 600 or 700. Let's see, red, yeah, 600 or 700 nanometers. And then you'll also notice that CO2 lasers are way down in the infrared at 10,604 nanometers, or about 10 micrometers. And then right above it, it says YB, yttrium? No, that's not yttrium. Ytterbium. Fiber lasers, 1,070 nanometers. So when we talk about, you know, I'm going to go buy a CO2 laser, the laser you're getting is putting out a wavelength of infrared light at about 10 microns. If you go get a fiber laser, that's putting out a wavelength of light around 1 micron. Okay? WidgetWorks sent me a picture of the label on his laser, and it said about 1 micron. So now the lasers you can get for cheap on Amazon that are diode lasers can be any one of a number of things, but the reports that I have is that the light from them is blue. And blue lasers are typically around 400 nanometers. Interestingly, 400 nanometers blue lasers also is the frequency of lasers that were used for DVD players and Blu-ray. And I was talking to my buddy Doug this morning, and he confirmed, because he was in that business for a while, he confirmed that is the frequency. So a lot of the diode lasers are a result of that industry, you know, laser reading of DVDs and such. So why am I telling you all this? Because what the laser does is completely tied to its wavelength. So if you take a fiber laser like I have, which is a 1 micron laser, and you fire it at a piece of plastic, generally nothing happens. In fact, I was engraving aluminum with my fiber laser, and I was holding the aluminum down with a piece of blue painter's tape, and the laser marking went over the blue painter's tape by accident. And what happened to the blue painter's tape was absolutely nothing. And I'm gonna give you a mental model for understanding why that happens. But the aluminum was being etched quite nicely by the laser. Similarly, I have this acrylic plastic that I use to make a larger splash shield for my grinder. In fact, John Saunders, I think, had some plastic cut also, similar thing. But I went down to our makerspace. Now, our makerspace has an Epilogue laser, gantry, big, lovely, same family of products as mine, so I know exactly how to use it. We see you, Carl. And it cut the acrylic plastic like it wasn't even there. It was very impressive. Whereas if I try to do that on my laser, nothing would happen. So the way to think about this is there's a couple of things that go on in laser etching, laser cutting. Number one, you have to get the energy into the material to basically blast the material away. And you can call it, heating the material. It's all the same. You're adding kinetic energy to the material so that it goes shooting off somewhere else. If you can't get the energy into the material, it's not going to do anything. And the second thing you have to do is the thermal energy that you're jamming in there has to be there long enough to do its job. So I started talking about cutting after my success cutting brass. I started talking about cutting copper, and a whole bunch of people said to me, "Oh, it's not going to work. You're going to be very unhappy with copper." Well, one of the reasons they said that is that copper is such a good thermal conductor that it's going to be very hard to do the work you have to do. And that's half the problem is getting the energy in, and the other half of the problem is keeping the energy localized. So for example, stainless steel has terrible thermal properties. So here's an example of this isn't stainless steel, this is tool steel, but it's the same idea, is that we're able to take a laser and do some surface heating in order to make a mark. So this is not an etching that I'm showing you. This is a 6-inch straight edge, by the way, with the Kinetic Precision logo on it. That is literally an oxidation mark made by the laser, and it's just a different approach. It's just surface heating. So what happens? Let's go to the acrylic plastic. Okay, so the acrylic plastic. So Carl is saying a bunch of things. I'm trying to absorb them. Carl says an important quality of a laser is the beam quality, which affects the ability to focus to a small spot, which is important for cutting. Absolutely true. He goes on to say that diode lasers have inferior beam quality compared to fiber or CO2 lasers. Because of the power, diodes are good for welding. Okay. And he says that copper is also an excellent infrared reflector. So interesting. I did a little research on this and this morning, and I asked the question, what is the best wavelength for cutting copper? And no, I did not use ChatGPT, so don't worry about that. And the answer was about 1,000 nanometers, which is 1 micrometer, which is exactly what I have. Now, that could have been an oversimplification because it's a metal, and that's the laser you use for metals. Not sure, but as Werner von Braun said, one experiment is worth 10,000 opinions, and I'm getting a piece of copper tomorrow, so we'll give it a shot. So in this piece of acrylic, the molecules are big. They're organic. They're organics, right? So they're these big molecules, and they could be polymers. And Carl's an expert in polymers, and so they get pretty large. So in order to get energy into those this structure made of these large things, you could think of big beach balls, you need a wavelength that's about the same. It's on order of the size of these things. So you would expect a larger wavelength, which is another way of saying lower frequency laser, to interact more strongly with those particles than if it was a piece of metal where the particles, right, the atoms of the metal, are very small. On the other hand, if you're trying to cut a piece of metal, etch a piece of metal, mark a piece of metal, you would want a laser with a smaller wavelength. And that will more likely interact with the smaller particles. So that's the rule of thumb. So if we go back to our spectrum, the smallest wavelength size of the lasers might be on this chart would be a green laser, right? 500 nanometers. A fiber laser is about 1,000 nanometers. And then if you were trying to use something where you needed a large wavelength, again, like for plastics or wood, which is another organic, the lasers with a big wavelength, CO2, would be the correct choice. Yeah, Carl says probably a 532 nanometer frequency doubled, so that there are things called frequency doublers. Niobium, is that niobium? YAG laser would be better, but very, very expensive. Evil says, I missed some stuff. Did you talk about eye safety yet? No. No, we didn't. Here's what you need to know. If you're going to look in a laser, okay, it's better to look in a laser that has short wavelengths than long wavelengths. But never look into laser with remaining eye. So that's the neodymium. Got it. Neodymium YAG, which is yttrium. I can't remember what YAG stands for. Give it to me, Carl. All the words, all the typing. So that's why there's different lasers. So if you run out and I've heard some people say, well, I've marked metals with my CO2 laser. And then there's a pregnant pause after I sprayed it with this stuff. So there's a spray, which is it's kind of like a ceramic spray. And then you mark it with a CO2 laser. The CO2 laser interacts with this special paint, we'll call it, and then it basically makes it cures what it exposes with the laser, and then you wash the rest off. The underlying metal is untouched, but that's the fix for dealing with CO2 lasers. The other thing you do is you could take a mug like my tea mug here, and in fact they did it. Where is it? No, they didn't do it on this one, but this is painted. So you can come in with a CO2 laser and you can evaporate the paint and not touch the metal. That's another way to do it. But now you understand why that's happening. Okay? Cermark, that's it. Thank you, Dale. Or I think it's Ceramark for ceramic mark. Yeah, Ceramark. Rommel correctly points out that's what you have two eyes for. Exactly. Okay, so YAG stands for yttrium aluminum garnet. So Carl wants me to go buy a frequency doubled neodymium yttrium aluminum garnet laser. What do I do after the divorce, Carl? I don't think that's a good idea. Okay, so here's the parameters. I got I got about 1.3 mils of cut depth per pass with my 30-watt fiber laser on brass. This is brass, like half hard, shim stock material. So if I have to cut 25 thousandths of an inch, there's going to be about 20 passes involved. Maybe that pass takes 2 minutes. So that's like a 40-minute cut time. Let's call it an hour cut time. I could still make parts as long as I don't want to make them fast. Can you make them at higher power and have it go quicker? And the answer to that is yes. And of course, just like every other cutting process, you're putting more heat into the part, so you have to consider total heat input, warping, etc., etc. But if you go to a company like Send Cut Send, I am not a customer of theirs, but I think they do some cool stuff. You can get stuff laser cut, and it's pretty inexpensive. Unfortunately, I actually checked on this project. They only go down to 40 thousandths thick material, with probably some really good reasons. So they don't go down to 25 thousandths. Robin says, I have 200. I don't know what 200 you have, but welcome, Robin. I need a little clarification. Oh, watts. You have 200 watts available. Holy cow. So I may borrow some watts, Robin. So you can go faster with more watts, and that's absolutely true. But for small quantities, for small prototypes, for thin materials, I do a lot of RF-y things where I need some weird shapes. It is totally doable. So I hope I explained a little bit about. Let me back up and give you some basics about wavelengths. Okay, so you may hear the term frequency, which is measured in hertz or cycles per second, and you may hear the term wavelength, which is measured in meters. So wavelengths in meters is equal to 1 over the frequency, 300 million over the frequency in hertz, or 300 over the frequency in megahertz. The 300 is the speed of light. So for you nerds out there, lambda equals C over F, right? So when we talk about high frequency lasers, like the ultraviolet end of the spectrum, high frequency is small wavelengths. If we talk about the infrared side of the spectrum, like CO2, big wavelengths is low frequencies. And the funny thing is that the entire range of wavelengths that we've talked about goes from about 500 nanometers up to 10,000 nanometers. So it's a 20-to-1 range. It's not a crazy range, but this is the range of wavelengths that are comparable to the size of the bits that we're trying to get all excited when we hit them with a laser. So if you own a laser, please go to the chat right now and just tell us, make and model and power and type of laser that you have, because I'm curious, and we'll share that with everybody. And I mentioned Unix Carbide is requesting to speak. Please stand by. Where are you? We have a live feed here. Here it is, folks. Live from Brooklyn, New York. Some serious road action at the local school. Is that not awesome or what? Thank you, Unix. I think Unix has the mic off because it's like loud and noisy there. But look at this action. So Unix built the fixtures to make these little cars, and I believe built the racetrack. Oh, we have a spin out. You guys on audio only don't know what you're missing. This is awesome. So I want you to imagine that these are laser beams. Thank you, sir. Thank you for the. I'll leave that up in the corner of the screen for everybody to be distracted by. Let's see who's got what. Ron Kellis has an X tool, 40-watt diode laser. Excellent. Dale has an SIC FU4. Sometimes I wonder, 20-watt fiber galvo laser. No shark yet. You'll get a shark, don't worry. So a gantry laser, which we described, you guys know what a gantry looks like. Well, a galvo laser is a laser with, oh, look, there's the parts that Dale bought at the hardware store. Oh, he's putting them together. So I'm pretty sure that, did I say Dale bought at the hardware store? Unix bought at the hardware store. I'm pretty sure that those were not laser cut. That was live. We're doing it live, folks. What a riot. So a galvo laser has the laser and two mirrors, one for X and one for Y, and a lens. And the head of that laser, it's a galvanometer. The head of that laser doesn't move, and just the laser beam gets steered around. Now, the big difference between a gantry laser, which has a bed size and the head moves around. Oh, there's a picture. Thank you, sir. The big difference is the working area. So a galvo laser typically has a small working area, and I think we were talking about it earlier, and it's either 4x4 or 6x6 inches of area, depending on lens used. Whereas a gantry laser is the size of the bed. So I have 24 by 12 inches, but it's not as fast because we're driving a mechanical head around. We're not steering a laser beam around. So it really depends on what process you're trying to accomplish. If you're trying to mark one part very fast, then a galvo is hard to beat because your marking is probably going to be pretty small. Robin has an IPG 200-watt yttrium fiber Q-switched 20 kilohertz to 1 megahertz frequency, 100 nanosecond pulse galvo. Holy cow, Batman. That's amazing. So 200 watts switch, 200 kilohertz to a megahertz. So one of the things that's of real interest to me, and I haven't done a study on this because I haven't had the time to do it, is what frequencies you use and by what pulse rates and pulse widths and all that kind of stuff. Oh, that's really cool. Oh, I know. I remember who that is. Okay, roger that. He says it was a gift from a very good Instagram friend. He is a good guy, if it's who I think it is. Ugly Skull has a 60-watt JPT M7 MOPA. MOPA. Don't know what MOPA means, but that's okay. So all of these lasers are pretty beefy, and just think back, not too many years, we couldn't have any of these things. So that is pretty neat. Cool, Robin. I want to hear more. But so Robin, if I asked you to cut out a 25 thousandth, yeah, I knew it was him. If I was going to cut out with your laser a 25 thousandths thick piece of brass, would you consider that fairly straightforward? Okay, so MOPA is Master Oscillator Power Amplifier. Okay. I mean, I like the sound of 200 watts. But so Robin has a Galvo laser. The other advantage of a Galvo laser is it doesn't take up a lot of space in the shop. It's not, you don't have to spend a lot of clutter credits on it. Whereas a gantry is at least as big as the bed. And I'm going to bring in Robin here to share some information with us. Let's see. Mr. Robin Renzetti, you have to accept the invite. And hello, good morning. How are you?
Oh, I can talk faster than I can type.
Yeah, it makes a lot of sense. So tell us a little bit
Yeah.
about your fancy laser.
Obviously a horrendously, unbelievably generous gift. That is not a cheap piece of equipment.
Yeah.
Along with all the other Galvo and everything else. And he drove it and delivered it to me from Ohio.
He's such a cool guy.
So yeah, a very good friend.
So
Uh,
just so everybody knows, this is the guy I bought my Brown and Sharp grinder from, my Micromaster that I had for a couple of years, doing great work, and I also got it from him. I bought it from him. So tell
Yeah,
us,
so
tell us more.
I actually have not had time to do much experimentation other than do the engraving stuff that I need for my work. Um, yes, I've cut through some things, but yeah, I haven't had much time to experiment with that. But obviously, it can remove material. I think it also the 100 megahertz frequency range is rather high because that's a enhancement that Eric talked them into unlocking for him on the laser.
Awesome.
So that's kind of unusual. Um, but the main thing, the one thing that I actually use the most in my experience is a lot of text is done by doing the outline because it's using an actual font, and then it goes in and does, multiple crosshatches or whatever
Mm-hmm.
to remove the material inside. I've found that works way better is using beam wobble, which is a feature to make while it's going through its motion, it does an orbit at the same time of a prescribed diameter.
Okay.
But you can only go so fast in your travel speed and maintain the wobble. So
Yep.
there's a limit to how far it can go. But I use a single line font, meaning it is literally just like drawing a pencil line.
Mm-hmm.
And then I use beam wobble, and that gives unbelievably crisp, perfectly filled characters all the time, even when you get down into the tiny, tiny, tiny. It just works really good. And now you go a lot slower, but with the beam wobble and everything and enough power, you can engrave just as fast. And in my case, I'm sure I could engrave these 10 times faster if I experimented more
Mm-hmm.
with settings. But it's for the little bit that I do, it's plenty fast. So I really am not a laser expert, but I can make this one do what I want, and it works very well.
I'm sorry. Did you just say?
I am not an expert.
I was just checking. So you have more settings to play with. That means this is a very deep hole.
Yeah, yeah. Now I did one thing I can pass along, and it's probably not any news to many people, but getting a relatively black finish on stainless. I have gotten that or on steel. I've gotten that fairly well tuned in, and a lot of that is from one of the keys there is defocusing.
Yeah.
Don't have the height directly at the correct focus length,
Mm-hmm.
um, and that works well.
Yeah, that's a really good point because we think of laser beams as literal straight lines, but really there is a lens involved, so there's focusing involved, and the defocusing is sort of a trade-off between energy dense. Well, it's not a trade-off. It's energy density. So if you want to cut something, you want maximum energy density, but if you want to just you could back off and heat up the surface to enough to oxidize, and that's what the defocusing would do. Otherwise, you'd be
Yeah.
literally etching the surface, right?
And I know that a lot of people use beam wobble in cutting also. If you're cutting deep,
Hmm.
sometimes beam wobble because it can make a path that's big enough that debris and stuff doesn't just clog the hole up instantly. It can help with that also. But like I said, I am seriously, I'm a real newbie on that. I just
Yeah.
learn what I have to learn for the project at hand and move on.
So Dale was telling me that he was dealing with cutting. I think it was brass, and came up with a technique of doing a high power cut and then going back and doing sort of a low power cleaning pass. So he called it a cutting pass and then a cleaning pass and then repeat another cutting pass, another cleaning pass. So that was sort of a technique for um, marching your way down through some thick material, which
I, some of the recipes I've seen, they call that an annealing pass also.
okay.
Might be just a different name for the exact same thing. But
Yeah, well, this black mark I got on the A2 was the epilogue calls that annealing, which is kind of correct, but it's really oxidizing, um, and it's really lovely. You could barely feel it. I haven't put an indicator on it, but it's effectively just an oxidation layer, and that's something that is another trick of
I
tuning.
find that they can be very directional, meaning you at your viewing angle on those can have a lot to do. You can view them um, from one angle and they kind of disappear, but you can get the right angle on them and they get very sharp.
Yeah,
So I don't know if that's just the settings that I've had or just don't have it tweaked exactly, but and I also know that for real industrial use, that's no good because it's too easily rubbed off.
yeah,
For at least the industrial stuff that we do, we want to mark that you really have to do something serious to get rid of it. So we usually go deep.
yeah. The epilogue literature calls one etching and one annealing, which okay, but it does work, and you get to do both. I had a I don't have it up here. It's down in the shop. I had a sample of each recipe on one piece of stainless, and it was pretty interesting. But 200 watts, dude, that's not messing around. Do the lights
It's
dim?
water cooled. It's got a water chiller, water unit that's as big as the laser underneath that maintains the water cool temperature, and
That
it's
is,
it's quite the it's quite the apparatus.
yeah. Dale says you can also use a laser to heat anodize titanium. I think it's the same process that I just showed, and I know at my makerspace we have a galvo laser, and one of our guys has been uh, creating the recipe for the different colors in titanium. So once you have the recipe, you could just feed it a picture, and it can kind of figure out how to use the laser to get a color image, which I think is crazy, but pretty neat. Well, thank you, Robin. I appreciate it.
Yeah.
We'll see you. We'll see you after the show in the where the finger sandwiches are. All right. Thanks, Robin. Okie dokie. So, does anybody else have questions here? We'll try to get them answered. Otherwise, we're going to wrap things up. So, if you've been thinking about getting a laser, those are the questions you have to ask: is what wavelength laser do I need? What materials do I want to operate on? How much power do I need? If you need a ridiculous amount of power for any possible application, go over to Robin's house, and he'll take care of you. um, the As far as costs are concerned for buying a laser for your shop, CO2 lasers are very uh, inexpensive. I think diode lasers are now getting into the same realm of as CO2 lasers. So-called fiber lasers, or the YB, what does it say? Is it y, I think it's yttrium fiber lasers. They're pretty expensive. The ratio CO2 to fiber laser in the epilogue lasers when I bought mine was approximately 5-to-1, 4 or 5-to-1, more expensive in the fiber lasers. But if you wanted to mark metal, that's what you had to do. Oh, the last funny bit of the story of marking the stones is that the stones, the grits in the stones, it's aluminum oxide. So when I mark the stones, it's not the stone I'm marking. It's the glue that holds the stone together. And that material is taking the mark. Because if I go to a pure aluminum oxide stone, like the 2-inch roundels, which I showed on Instagram this week, okay, these cannot take the mark because they have a completely different chemistry holding them together, which is interesting. So that's why, you can make the argument that, gee, how can you mark that stuff? It's not markable. Well, that's why, because it's really marking the glue. YB is terbium, not yttrium. You chemists, you have a name for everything. Ron says X-Tool 40-watt laser, 40-watt fiber head is $500 US. Don't remember the advertised capability. Yeah, there's stuff out there. Dale says for a good one, there's some cheap Chinese fiber lasers out there. They don't last a long time, but they're cheap. It may be cheap, but it's cheap. Okay, so let's see. I have some announcements before we go. There will be a PFG.Live holiday for the next, I guess it's the next 2 weeks, December 22nd and December 29th. We will not have a PFG.Live. We will be back on January 5th after we recover from all the holidays. So we'll see you guys, nothing on the 22nd, nothing on the 29th. We'll see you back on the 5th. Thank you very much, Doug Chin, for the bagel. The bagel you see now in the lower left-hand corner of the standby screen is an actual Doug Chin bagel. There it is. And I get a call from Doug this morning. I get a text from Doug. Are you awake? I'm like, well, yeah, I'm not vertical, but I'm awake. He says, come on over. I have fresh bagels that need photography and eating. So I went over there and we took some pictures of Doug's bagels, and one of them has replaced the stock photo that was on our slide, which you will see in a minute. And I want to say thank you very much to Doug for the bagels. I guess that wraps it up here. We'll see you guys coming over in the after party roundtable on the Discord server. We'll see you on Instagram variously this week. And we might have some random lives between now and January 5th. In the meantime, get flat, stay flat, remain coherent, and we'll see you next time. Take care.